achievement here. And to go further, we are going to need some lem, this lem exactly. So we are going to prove that for any set of real numbers, Cj holds this inequality. We are going to prove this like that. Let's rewrite the left part of inequality squared plus some integer, some positive number both I, j from 1 to k, ci minus cj squared. So we see that the left part of inequality is here, and here is some positive number. And we are going to decompose this. Okay, this is the square of a big sum, so it is actually the mutual product for any ij from 1 to k of cy, cj. This is our first term here. And now let's decompose this difference. It is ci squared plus cj squared minus 2ci cj. And if you fix, for example, j here in this sum, there will be k different i's for this j. And if we fix I, there will be k different j's for this y. So what we have here is actually plus 1/2 k sum over y equal to 1 up to k ci squared plus 1/2 k. That's for second term. This was for the first term here, and this is for the second. So j from 1 to k cj squared and minus 2. And these two self-destruct, so we just have the sum over ij from 1 to k ci cj, which self-destructs with this, and everything becomes equal to k sum over j from 1 to k cj squared. So we add to the left part of inequality some positive number, and we get the right side of inequality. So we have just proved this inequality, this lem. So we have our expression for the middle part here, and we have our lem. And let's recall that phi is a unitary vector, which means that that's sum over all j's j star conjugated equals to 1, which is the sum over all j's of a squared plus b squared. And that means, since that this sum equals to 1 and both its components are positive, that means that the sum over all j of aj squared less or equal than 1. Now we can multiply this inequality by n, get this. And to this we can apply our lem here, so it will be greater or equal than this sum over all j of aj and the whole sum squared. And this gives us that the sum of aj over all j is less or equal than the square root of n. So we can, instead of this here, we can place this square root, and as you remember, we will get this right side of inequality. So we just proved the right side, and in the next episode, in the next lecture, we are going to discuss the left side.